So to answer your question about the connected grid and how it is driving energy efficiency, I can tell you today that it's driving it in multiple ways, and I think in the future, even more impressive ways. So you can imagine a connected thermostat, or you can imagine any sort of connected load control device. The ability to consumers to interact with those devices to manage their energy in a much more efficient manner have driven down energy cost for customers, in some cases up to 10%. So in some regards, Intel and the market actors are replacing carbon with the silicon that is embedded in some of these systems. I think in the future, those embedded systems and silicon inside those embedded systems, like rooftop solar, like EV chargers, like energy storage devices on the side of the home, will drive additional energy efficiencies. One, from the grid and the market actors to be able to forecast load in a much more fine, detailed layer. I think it also opens up an opportunity for the owners of those devices to actually participate in market activities. So Intel works with all the major utilities and energy players in the market today in one way or the other. I mean, Intel's a long history in the PC market, a long history in the server market. We're working with utilities, enterprises across, not just in the utility space, but also in the oil and gas space. Or the best value we provide is sharing best practices across the different markets and different utilities we work with. So we come in, we work with utilities across the different departments, whether it's customer facing, grid ops, or even on the energy trading side. Learn a little bit about what the challenges are, and then again sharing best practices with some of the other utility projects that we're working on. So one of the ways that we're working with utilities is to create kind of an Internet of Things layer between their legacy systems and these new systems that are being deployed in the field, to allow them to gain more transparency into what's happening as consumers adopt these new technologies, be able to forecast better based on these new devices that are being deployed in the field. And I think also from kind of an asset management and predictive maintenance layer, being able to see really what's happening, what the impacts are on substations and devices that are installed on the distribution layer. So two different pieces, two very different pieces, but I think they tie together from an IT perspective.
Right, and you have algorithms and data running end to end through that whole value chain.
That's correct. I mean, one of the first places we start with utilities is to help them and guide them on the formation or I guess standing up of these what we call data lakes, or these data platforms that take in unstructured data and then allow them to take those different data streams and create insights into, again, what's happening on the grid in ways that they haven't really done before. It adds on to the legacy systems that they have already, smart meters, smart reclosures, all the other devices that have been deployed in the field. This is an additional layer of data dumped into like a Hadoop cloud instance, and then allows them, again, to create new data products that they can operate more efficiently, or potentially offer new products and services based on the kind of data that they're collecting on that end. So I think on the customer-facing side, there is a growing trend across the world around market restructuring, and in countries like Japan, where in April of next year, the market opens up to competition, and different players in that market are now offering, or will be offering, energy services. So the energy itself delivered almost becomes a commodity inserted inside a much broader value proposition. And the value prop is smart home, potentially a smart home platform with the energy commodity allows a customer to manage and track the energy better, maybe control the energy better. And this bundling of products like smart home or other kinds of products that would go into the home, or maybe potentially better pricing programs, all designed as a way to acquire a customer.
Yes.
And potentially, if you're the incumbent, retain a customer.
Mm.
So this is technology driving new business models in areas where the utility has not been, is not really comfortable with, or potentially not, doesn't have a history.
Yeah.
So Intel is working with those companies to help them move and evolve from kind of a grid-facing company now to more of a customer-facing company. First and foremost, it needs critical infrastructure protection. A system thought about in the beginning that can protect the sharing of information, can protect the control and access to those devices. I mean, you can imagine, as I don't know what the actual number is. It sounds like it's probably in the billions, but that is, every new device that gets deployed on the grid is another security risk point.
Yes.
And being able to put a platform in place that can grow as IoT grows, I think, is incredibly important. I think the other is an operating system that can manage the devices, authenticate devices, know where those devices are on the grid, is also very important. So something else to think about as the explosion of IoT grows. And I think finally, the ability to track and manage those devices for load forecasting is another incredibly important piece of that. And I think everyone would agree that it's growing, and maybe, hopefully we're doing a pretty good job of predicting the size and growth of that.
Yeah.
But as it grows, I think one of the real challenges is the ability to seamlessly integrate a disaggregated group of devices. You can imagine a day where you've got a solar provider putting in rooftop solar, you've got people with electric vehicles that are wanting to plug into the grid from 8 different manufacturers, you've got 8 different smart thermostat manufacturers. There's any number of proprietary solutions that are being deployed on the field, whether they're utility owned or consumer owned. All of those assets have value to the grid and to the market. So finding a way to pull all those into the grid in a seamless fashion, I think, is one of the biggest challenges that the industry faces today. And Intel is very much in the middle of that, working with utilities that are facing the challenge today. I think first it's field level integration to those devices, with field level decisions being made with gateway devices that potentially are installed on the grid itself. So you can imagine a day where if a utility is relying on intermittent resources as a reliable resource for the grid, and it's sunny or rain, or it's not sunny, it's cloudy, the wind stops blowing, there needs to be a way to automatically route and change the resource. And sometimes I believe it's going to have to occur at the field level, as opposed to all the way back at the grid ops level. Because I think the telemetry has to happen very quickly. So I think there's an IoT component there. But the IoT component at that level, I believe, needs to be open. There needs to be some architecture, reference architecture, if you will, to all of the devices that are being deployed in the field, so that the utility and grid, again, be able to pull them in seamlessly, create the edge compute that they need to compute, and then also be able to use it for load forecasting. So I'm going to go back and maybe defend the utility industry a little bit in terms of its investment in IT, and then talk a little bit about where it's going in the future, or at least where I think it's going in the future. I think because the utility business model has been virtually the same for the last 100+ years, and there's been centralized generation delivered to the end user through a traditional T&D system, and the real focus in that business model has been reliability. And keeping the lights on and managing outages and providing the kind of customer reliability and customer service that we've all come to take for granted potentially. I think the new business model is being driven by the things we've already talked about. I think the new energy model really focuses around the customer, where the old business model really focused around the grid assets, whether it's generation or grid ops.
Yes.
So I think all the new IT investment is going to be in focusing around the consumer and the edge of the grid. And I think that's an area, because the old business model maybe didn't require as much IT in the edge. I think the new business model definitely does require IT investments. And IT where it marries and converges with OT. So you can imagine from an operations technology perspective, embedded compute, embedded devices inside things that are being deployed on the edge, merged with IT back in the back office to be able to see what's happening on the grid. And I think that's the real play in this industry, and I think that's where you'll see a lot of the new investment in IT. I think it's really around, for me, two areas. One, it's the sharing of personal information. I think we're moving into a day where everyone's heard the term prosumer, where
Yes.
consumers are consuming electricity, but they're also producing electricity. And those prosumers want to get in the game. That's going to require, I think, sharing of personal information. Where is the device on the grid? How are these prosumers using their energy? Real in-depth user profiles that need to be secure between the consumer and the market and or the utility. Even meter data itself, interval usage data, which is a new source of data that's very valuable to utility. That data could be in the wrong hands, can be used in the wrong way. So I think being able to put security around that interchange of information and potentially even interchange of dollars between a user and the market must be protected. I think the other piece that needs to be protected is the actual devices themselves, putting a firewall, if you will, around those devices so that potentially you can't go in and change your thermostat at 104 degrees in August in Texas and somebody hacks the system and lowers your thermostat, you come home and
Right.
So those are the kind of things that I've heard Brewster from Pecan Street talk about. I think it starts with being able to ingest unstructured data, a platform that can do that, because we don't know in the future where the data is going to come from, what sources it's going to come from. So I think that's step number one. And I think step number two, again, is know what you're trying to accomplish. I mean, there's tons of data, everyone knows, coming off the grid today, coming from consumers, some proprietary, some not. But I think the real challenge is, what do you want to do with it, and then build your system accordingly. I mean, I think everyone knows the spread of market restructuring and competition in the market is growing.
Absolutely.
Markets like Mexico, Japan, Germany, they're all facing the same kind of challenges. So being able to take what we've learned in certain markets and then take those into the others to help from an advisory perspective, those lessons learned to help them create programs that help them become successful. For me, personally, I think it is an emerging trend that I embrace completely, and finding ways, we talked about the interoperability platform, but finding ways to pull the customer into the markets, if you will, and use, again, the silicon and the edge computing capabilities to really help utilities navigate the new energy model, where carbon-based assets are riskier, and renewables and goals for renewables continue to increase. So really looking forward to, in the future, working with more utilities that want to create interesting bundles of products and services that drive the customer to participate at a higher level in the new energy model.